This to my ever present 3 viewers. Let's start this. Click on this, make it a little bigger, and go. So, first one says dilate triangle ABC using point A as your center dilation. So, this is your center. So, everything is going to be based on that center. So, the distance that B is from A, that's the distance that's going to be increased or decreased by scale factor. And the distance from A to C, that's the distance, right? It's going to be increased or decreased by whatever scale factor. So everything starts from the center dilation. So it says here, dilate triangle ABC. So let's start with point B. If you told me from A, our center, so where everybody's standing on A, to walk to B, I would walk 3 units. 1, 2, 3, and then we get there. So if I'm dilating that distance by a scale factor of 3, you multiply 3 times 3, and now it should be 9. So B, after a dilation of scale factor 3, would be 9 units away. So let's count from A, 1, 2, 3, 4, 5, 6, 7, 8, 9. There, ladies and gentlemen, is B prime. C prime, sorry, C. Well, I want to get to C prime. Point C. If I were on A, and you told me to walk to C, I would go 3 units that way. Oh my god, did I just mix an arrow? 3 units that way. And then I would go 2 units down. If I am going to use a scale factor 3, we're going to multiply that by 3, and we're going to multiply that by 3. So now it's going to go 9 units that way, and 2 times 3, 6 units down. So let's do that. So with C, we're going to go 9 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6. And there would be C prime. Now, A prime would be on top of A because what's the distance that A is from A? It's 0, right? It's on top of it. So if you multiply that by 3, you still get 0. So A prime would be right on top. Okay. Now, if you want to, or get a different color, we're going to connect that, and connect that. Now, what you also can notice that in the original triangle, this was 2 units, this was 3, right? And in the dilated triangle, this distance is now 9. This distance, that's now 2. It's 1, 2, 3, 4, 5, 6, right? So let's go back to similar shapes, right? Corresponding sides. The ratio of 2 sides and its corresponding sides are proportional. Okay. Isaiah claims that figure BCD, this one right here at the bottom, is a dilation of figure B using point A as a center dilation. So here is our dilation, center dilation. So let's do one point at a time. Let's talk about B. So if I were to draw this, so here's point. If you were to walk to B from point A, that's how much you would walk. Right? So let me take that guy here. That's how much you would walk. So they're saying, and if you were to walk from A to its dilated point, it would be from here to here. Right? Did that original distance that original distance, does it look like it's a scaled version of the original one? It does. And I'm going to say that's 1, 2, 3, a scale factor of 3. So, right? So it definitely looks like the distance, the original distance of AB was scaled up by a factor of 3. Let's look at point C, AC. So if you were at A and you're walking to C, that's how much you would walk. And if they said, hey, use a scale factor 3, that would mean that that distance will be increased by 3. So let me see if I can draw one right on the side. Oops. Right, so I'm going to take that and then increase it. And it should be 3 times. And if it is, we're in a good spot. So work this that way. So think about that. Is that 3 times the original? 1, 2, 1. No, actually, this is a little bit longer. Look at that. That's 1, 2, 3. Or did I make that too short? Yeah, I made that too short. Well, yes. So it is 3 times, which matches the dilation that we did from AB to A prime, B prime. What about the last one over here? Let's measure the distance AD. Let me make it nice this time. And then let's measure the distance when it's scaled up by 3. Let's see if that matches. It doesn't seem like it does. Uh-oh. Because, am I? 1. Oh, this definitely not. So, is this is figure BCD a dilation of B prime, C prime, D prime, dilation of figure BCD using point A as a center dilation? It doesn't look like it because it fails here. Everything else looks like it was scale factor 3, but here, look, this was AD, and if you scale it up with a scale factor of 3, it should be 1, 2, 3. Point D should be all the way down here. Point A works, right? Point A works. 1, 2, point C, even point C is a little bit off. So you can use that, right? You should say that the distance, all the distance, these 3 original distance, were they all dilated with a scale factor of 3? I thought they did, but definitely didn't. Right? So it definitely fails here. It fails here. There's no way that this distance and this distance, it's 3 times the original. No, so it fails there. Okay. Let's see. Quadrilateral ABCD is dilated with the origin as the center of dilation. So let's go to the origin and put a little 0, 0, a little dot there. So everything has been dilated from this point. So the distance that's dilated is the distance that you are from the center of dilation. So what is a scale factor of dilation? Well, look at point A. Point A was -6, 2. What does that mean? It meant that if you were at the center, right, you have to walk 6 units to the left and then 2 units up. That's what -6, 2 means. Now, A prime, so that's point A. Now, look what happened to A prime. A prime is now -3, 1. So that means to get to A prime from the center, you walked -3 to the left and 1 up. Can you see a relationship between 6 and 3 and 2 and 1? How does point A and point A prime relate to each other? Well, point A prime is half, right, the distance to the center of dilation as was A. So the scale factor was a half. Can you use that information and figure out the other points? Well, yeah. Let's go to B, which is 4 and 6. So instead of 4 and 6, if you take that in half, B prime would be 2 and 3. So I'm going to write B prime. Just half of that, 2 and 3. So you, instead of walking 4 to the right and 6 up, you're going to take half of that, which is 2 right and 3 up. Point C prime, it's 6 to the right and 4 down. No more. It's 3 to the right and 2 down. D prime is 2 to the left and 2 down. Not anymore. It's 1 to the left and 1 down. cutting them in half. Consider rectangle WXYZ, which is on the right. Sketch the image of the. We got two dilations. So first of all, well, if you leave it you can leave it at 3/2, or 1.5. Either or. So again, where's point? Let's do point M. So think about W. So let's talk about W. From point M, which is your center of dilation, how would you walk to W? You would go 2 units that way, and then 2 units up. So we're going to use a scale factor of 3/2 or 1.5. So multiply 2 times 1.5, you would get 3. So instead of 2, you would now 3 to the right, and then 1.5 times 2 again, 3 up. So point W prime would be 3 to the left and 3 up. That's where W prime would be, using a scale factor of half. X. So from our center, how do we get to X? All right, so from our center to X, we would walk 1, 2, 3, 4, 4 to the right, and 2 up. Multiply both numbers by 2.5, so you get 3 over here, and you get 6 over there. So now to get to X prime, we go 1, 2, 3, 4, 5, 6, and then 1, 2, 3. There's my X prime. Z. Well, to go to Z, I would go 4 to the right, and then 2 down. Multiply both numbers by 1.5. It means that you're now going to go 6 to the right and 3 down. 6 to the right, and then 1, 2, and 3 down. That's Z prime. To Y, to go to Y from our center, we go 2 to the left and 2 down. Multiply that by 1.5, our scale factor, you get 3 to the left and 3 down. Notice that we have a figure that is now similar, meaning the ratio of 2 sides and their corresponding sides on the other shape are proportional. So here's my shape, and that would be it. Oops. Now the second one, so I'm going to erase all that. We want a dilation against the same point M, but instead of scale factor of 3/2 is a half. So everything gets cut in half. So let's do W. To go to W from point M is 2 to the left and then 2 up. If you cut that in half, it means you go 1 left, 1 up, which makes W double prime here. Y, from M to Y is 2 left, 2 down, or 1 left, 1 down. So there's Y prime, double prime. To go to X, it was 4 to the right and 2 up, or 2 to the right and 1 up. You can sort of cheat, right? I mean, we can all know that Z has to be here, even without doing anything, as long as you understand. So that's the dilation with center M. Triangle RPQ. Ooh, different. They're asking you, where is the center of dilation? So here's a little trick you can use. I remember that if this is center dilation, and I'm standing here, let me call it A, this is the distance that's being dilated, right? So A prime, if I say, let's say, just use a scale factor of 2, A prime cannot be over here, right? It's from the center of dilation, that same distance, just double that distance, right? So A double prime could be twice that original distance, right? It won't be there. If you did it over here, that's wrong. If you did it over here, that's wrong, right? So it has to be on that same line, right? So if you think about that, they have to be on the same line. Let me draw a line from, because these two triangles were dilated. So obviously, point R exaggerate a little bit. Make sure they're on the circle. Make sure this is on the circle. There. No, not there. There. No, not there. Okay. Right. So somewhere in this area is our center, our center of dilation. Now, to be precise, I'm going to draw another line, but I'm going to go from here. Right, so same thing. Just go over here, and where those two lines crisscross, it's our center of dilation. Oh, shoot. Oops. All right, so obviously, the more precise you are, the better this is going to look, and it looks like, okay, that's better. And then let's see if I can do this one, because it looks like it's pointing this way, right, guys? There we go. Oh, so where those two lines meet, and if you wanted to do one more line, right? Let's do this one. Just do a better job. Let's make sure it goes to both. And it looks like a center of dilation, right? It's right here. Right there. Well, let's see if we're correct. All right, let's see if I remember the points. Keep that point in your... So this is where all those three lines intersected. Let's see if that's right. So that's right. Triangle RPQ, that's the original, got bigger. Okay, so let's figure out how do we go to Q. To go to Q from our center of dilation, right center, I would go 2 to the right and 2 up. So to go to Q, go 2 right and then 2 up. So point Q now after dilation is point M. And to go to point M, we're going to go 3 to the right and 3 up. So to go to point M, it's 3 to the right and 3 up. Actually, one of these should be up. Right? So what was the scale factor? How did 2 become 3? Well, in order for this distance, right, this distance, somebody multiplied that 2 and that 2 to become 3 and 3. So what did I multiply these two to become 3 times 1.5 times 1.5? So there, it looks like the scale factor is 1.5. Let me try something else here, just to make sure. Let's compare P and M. So to go to P, I would go 1, 2, 3, 4, and 2 up, right? So to go to P, I would go 4 to the right and 2 up. To go to M, it would be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. It looks like to go to M, 6 to the right, and then 3 up. Well, just to confirm, if I take 4 and 2 and multiply both of them by 1.5, 2 times 1.5, do I get 3? Yes, I do. If I multiply 4 times 1.5, do I get 6? Yes, I do. So you can tell this is actually the center of dilation, right? So the distance to go to P, right, the horizontal distance and the vertical distance were both multiplied by a scale factor of 1.5. Nice little problem. Dilate rectangle ABCD with point N as the center using a scale factor of a half. So, again, right now you should be tired of this. Here's the center. So let's walk to A. To go to A, I would go 1, 2, 3, 4, 5, 6, 7, 8. I would go 8 to the left. I'll use arrows. And then 2 up. So it's a dilation of a half, right? A scale factor of a half. What's going to happen to both distances is going to be cut in half. So instead of 8, I'm going to go 4 to the left. Instead of 2 up, I'm going to go 1 up. So 1, 2, 3, 4, and then 1 up. So A prime B prime, sorry, B. To go to B, I'm going to go 2 left, then 2 up. Cut that in half, it means 2, 1 up, and 1 left. So 1 left, 1 up. There's B prime. To go to D, I'm going to go, I know it's 8 left, and then 1, 2, 3, 4, 5, 6. So 8 left and 6 down. Cut that in half. 4 left, 3 up. 1, 2, 3, 4, and then 1, 2, 3. So here's point D prime. And obviously, we can just kind of cheat and see that point C prime is over here. Okay, so this is the dilation of a half with N as your center of your dilation. Okay, refer to line segment ST and its image ST under a dilation. Use a ruler to draw the central dilation. Label it point R. So again, remember that trick? So remember when I put Daniel and Dylan, this was Daniel, and then Dylan was here. Right, Daniel and Dylan. Right, and I asked Sarah to stand, right, based on their distance to stand behind Dylan when using a scale factor of 2. Well, Sarah has to stand in the same line, so she had to stand somewhere over right here. Right, Sarah would not be standing over here because that doesn't make sense, because this is the distance, right, that was dilated. So scale factor of 2 takes that distance, double it. If it was 3 times, Sarah would be over here. So notice that they are all following the same, right, the same line. So because of that, we can use that little trick. So here is Sam, and then somebody's standing behind Sam after a particular dilation with a particular scale factor that we don't know yet, but we're asking, hey, where is the center? Where is the center? Is the center over here? The center over here? Where's the center of dilation, right? Where's our starting point? So get a ruler, make sure it goes through both circles, extend it a little bit, be as precise as you can. There, that looks okay. I changed a different color. I'm going to take point T and T prime, and actually this looks pretty good. So where they both meet is our center of dilation. So this problem started here. Let's see if that is correct. So if you all right, so look at this distance right here. Then look at this distance right here. Does that the second one look like double the first one? It does, doesn't it? As best as I can. So if I were to guess on a scale factor, I said the scale factor would be 2 because it got double, and here would be my center of dilation. What is the scale factor dilation? Explain or show your thinking. I just did that. Choose a point on segment ST and label it U. Find the precise location of U. The image of dilation is. Oh man, I missed that. Let me repeat this. Clear background. No, clear something. Really? Okay. So let me repeat the problem. Let me find the center of dilation again. Just move. Okay, that, right? Connect those two, make a straight line. Connect these two, make a straight line as best as possible, right? So where they intersect, it's going to be our line of, our center of dilation. So this is where it all started, right? So I asked Daniel to stand there, then Sam came over, stood over here, we changed color, and then I asked someone to stand. Does that look like double? I asked, I don't know, Samantha 2 to stand double the distance, the original distance, double the original distance this, and let me see if that matches. Yeah, look, it does. Right, it's double the distance. So scale factor is 2, and the question they're asking us to do right now is choose a point on segment ST, call it U. Let's call here a point. Let's call this point U. And find the precise image of U prime in the image of the dilation of U. Okay, so if we were to double U, where would it be? Well, we can use this line, right? Right, so there would be U, that line, and then let me just, move it. Oh, I can't move it. All right, so where would U prime be? If I continue that line as best as I can, U prime would be right here. Okay. Dilate this using scale factor of 3 with point P as a center of dilation. Okay, so point P. How do I get to X? To go to X, clear background, objects. What happened? Right, so think about this. If you were at center of dilation and you're P and you want to go to X, you would go 1 that way and 1 up. The scale factor 3, we're going to increase everything by 3, so times 3 times 3. So we're going to go 3 to the left, 1, 2, 3, and 3 up. 1, 2, 3. And there's your X prime. Y, so from P, you go 1 up and 3 to the right, so 1 up. 3 to the right, which would, if you multiply by 3, would be 3 up. 1, 2, 3, and 3 to the right. Sorry, 9 to the right. 1, 2, 3, 4, 5, 6, 7, 8. That would be right here. Let me erase all this out. It would be 9 right here. And that would be Y prime. To Z, to go to Z from P, it's just 1, 2. There's a scale factor of 3. 2 times 3, 6. So 1, 2, 3, 4, 5, 6. So that original distance get multiplied by 3, and we get Z prime. Draw the shape out. Sorry, connect dots. And you notice that it's the same exact shape, right? But where the dimensions are 3 times as big. Just to confirm, look, here the dimension of this side, the side is 1, 2, 3, 4. So this X prime, Y prime should measure 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ta-da! Next question. What is a center dilation? Oh, a center dilation is right here. Wait a second. Where is it? Right. What is a scale factor? Well, center of, what is that? If this is a center of dilation, right? Let me write center. So, first of all, we had triangle FHG, which you can clearly tell is this triangle that I'm highlighting in red. And the other one has F prime. Is there an F prime? Well, I should have an F prime, H prime, and G prime. So that's how I know this is the original, right? And this is the dilated one. So, center dilation is where everything starts, and that's the distance that you are from the center dilation is what gets scaled up or down. So, let's look at the easiest one. Let's look at this guy here to here. That's your center of dilation. Let's see if I'm right. It takes 2 units to get to H. So to get to H, you get 2 units. To get to H prime is 1, 2, 3, 4, 5, 6, 7, 8. So H prime would be 8 units. What was the scale factor? Times 4. Let's confirm this. Let's confirm this. Let's confirm that the scale factor is really 4. So we're saying that the scale factor is 4. Let's go to G. So here's my center of dilation again. My center. And to go to G, I would go 2 to the right. And then I would go down 2. 2 to the right and down. Oops, sorry. Down 1.5. No, sorry again. Not 2 to the right. Notice that it's not going 2 to the right. It's 1.5 to the right. And then down 1.5. And down 2. Apologies. and down 2. So 1.5 to the right and down 2. So if you multiply that by 4, we're going to go 1.5 times 4 is going to be 6 to the right. 1, 2, 3, 4, 5, 6. And then how many units now? 8 down. So that probably brings us to here. So this seems like the right thing. So that's your center of dilation. And the scale factor was times 4. And so let's try this. So my center of dilation. Okay, that's a pretty good line. Try another line here. And remember, where those two lines meet, which according to this, oh my god, I don't know why the lines keep moving, so let me move it. Okay, there. Oh no, battery. There. And there. Okay, so it looks like our center of dilation is right here. That would be 1, 2, negative 2, and 3 up. Looks like a center of dilation. Okay, so let me remove this line. And actually see if that's truly the center of dilation. So let's walk. So here's my center of dilation. Let's walk to A. To walk to A, I would go 2 to the right, and then 2 up. 2 to the right, 2 up. Good. To walk to A prime, I would go 1, 2, 3, 4, 5, 6, 7, 8. So it would be 8 to the right, and then 1, 2, 3, 4, 5, 6, 7, 8, and then 8 up. Well, what's the scale factor? Times 4. Alright, so here's my scale factor. 4. Let's see if it works for the other points. Let's double check. So let's walk to let's walk to B. So let's walk to point B. So to walk to point B, I would go 1, 2, 3, 4, 1, 2, 3, 4, 5. I'm going to go 5 to the right, and then 2 up. Walk to point B. That's my. So to walk to B prime, if I'm correct, scale factor of 4, 5 times 4 would be 20, and then 2 times 4 would be 8. So I'm going to go 20 to the right and 8 up. Oh my god. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh my god. Look, 20. And then how many up? 1, 2, 3, 4, 5, 6, 7, 8. Ah, so the scale factor of 4 actually works. I'm not even going to do C. So, there's my center of dilation. And there's my scale factor, which I'll write. Everything is times 4. I did something silly. I could have just found the scale factor this way. So, look here. What's that distance? Is 3. So this, well, we already know the scale factor is 4, should be 12. Let's see if I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We could have done it that way too. Okay. But we wouldn't have found the center of dilation. So, it's all good. Last question. I don't know what this question is about. Instructions. Dilated using 0, 0 as a center. He graphed point B. What scale factor did he use? Okay. And then complete the dilation. All right. Okay. Scale factor is 0, 0. Sorry, some dilation 0, 0. So if you wanted to walk to B, how would you walk to B? You would go 1, 2, 1, 2, 3 to the right, and 1 up. So to B prime, how did they go to B prime? Well, from the center again. 1, 2, 3, 4, 5, 6. They went 6 to the right. And then they went 2 up. Obviously, the scale factor is 2, right? Because that vertical and horizontal distance got multiplied by 2. Simple? Yes. So now they're saying do the same as the rest. Well, A. To go to A is 2 left and 3 up, so it's going to be 4 left. 1, 2, 3, 4. 1, 2, 3, 4, and 6 up. 1, 2, 3, 4, 5, 6. There's A prime. C, from the center, which is the origin, it's 1 right and 1 down, or 2 right and 2 down. There's C prime, just doubling everything. To go to D is 3 left and 2 down, or 6 left and 4 down. 2, 3, 4. And D prime. So it's always nice to connect the dots because you can see if the shape is the same. And you can clearly tell it is the same shape, but the dimensions are double. That's that. I think that's it. Okay, so that was your review.